So good afternoon, everybody. Thank you for joining and helping us migrate all of our applications from on-premise to cloud in the next 35 minutes. I have this clicker that Deepak suggested. We'll see if it works.
I was looking for it.
We'll see if it works. So before we get started migrating our applications, I have a question. Category is cloud computing. Question is, in what year was the term cloud computing popularized? So think about that. I should give you three choices, A, B, or C. So by a show of hands, who says the answer is A, 1996? How about B, 2006? Got 1, 2 hands, 3 hands, okay, 4 hands. How about C, 1882? Anybody? Well, it seems like 2006 wins out, and that actually is considered the correct answer. So, all right, we're all on our way here. 2006 is the year where generally it's accepted that the term was popularized, particularly because that's when Amazon started to come out with its AWS, Amazon Web Service. 1996 is considered the first year where the term actually appeared in any sort of paper. So it actually appeared in some journals, but wasn't widely popular until about 2006. What about 1882? It's long before cloud computing, or even computing in general. But it was an interesting year. It was actually the year of the very first central power station. September 4th, 1882, Thomas Edison's invention went live in Lower Manhattan, lighting up a few blocks on Pearl Street, totally revolutionizing the way businesses conducted business at the time. Now, before 1882, businesses, in particular factories, were able to run off of electricity, but it all had to be generated on-premise, right alongside the factories. Starting in 1882, we begin to see the emergence of the electric utilities, whom, through economies of scale, were able to offer electricity cheaper, on demand, and without the need for on-premise equipment. Many of the same benefits that we talk about with cloud computing. And if you're interested in reading more about that particular topic, I recommend a book by Nicholas Carr called The Big Switch. In the way of introductions, my name is Michael Miner. I work at Oracle Corporation, Director of Engineering in the Fusion Middleware organization. The Fusion Middleware set of products actually have been so-called migrating from on-premise to cloud. Originally offered as on-premise offerings, the Fusion Middleware stack is now being made available as cloud offerings. So let's talk about, first of all, why are we doing this? Why are we trying to even think about migrating our applications from on-premise to cloud? We talked about some of the benefits similar to what we saw with the electric utilities. Cost is one. We can reduce cost by moving our equipment off-premise, renting them, so to speak, from a cloud vendor. Scalability. Cloud vendors are much more adept at being able to scale within a region or across regions. Speed, the speed at which I can create an instantiated environment. Of course, no need for on-premise equipment and maintaining and managing that equipment. And also, the fact that I no longer need to manage that infrastructure. Now I can focus on the business, more about the application, and less about the infrastructure. All this is accomplished by cloud vendors having the economies of scale, because cloud vendors are looking to provide hardware, perhaps even infrastructure, software infrastructure, across various companies, which helps them gain economies of scale. We'll talk about that a little bit later. So let's define first some of the terms that we're using. What do we mean by on-premise? We're talking about software and hardware that's inside of the premises of the organization using that software. For, let's say, if we are trying to migrate our applications from on-premise to cloud, and we're located in this building, perhaps we're talking about on-premise equipment that's right in this very building. This is a definition from Wikipedia. For those who don't like Wikipedia, let's move up the scientific stack, so to speak, to the NIST for a definition on cloud computing. So here we're talking about on-demand access to a shared pool of resources, whether it be network, servers, storage, or even applications that could be rapidly provisioned and then released. When we talk about cloud, and we talk about migrating to the cloud, there are different deployment models that we need to consider and different service models. We need to know how we're going to move to cloud and what sort of cloud we're talking about. When we talk about deployment model, we typically think of public cloud. That is going to a cloud vendor that's out there in the public, moving from our on-premise to a vendor that's in a different location, perhaps an Amazon, or perhaps even an Oracle. But there's also the notion of a private cloud. That is providing the same benefits of cloud, the ability to on-demand provision resources, but that cloud is actually located on the organization's premise. And then we can talk about hybrid cloud, which is a mixture using public cloud and private cloud in some sort of hybrid fashion. Then we also need to consider our service model. When we move our applications from on-premise to cloud, are we talking about moving it to an infrastructure as a service, or a platform, or software as a service? 3 different levels that are available in the cloud. Here we can see the different service models available to us. If we look at our package software, which is really about our on-premise software, on-premise, our organization is responsible for everything, from networking, storage, all the way up to the application. As we move those applications to the cloud, depending on which service model we choose, we're going to be taking advantage of the different layers within the cloud. If we talk about moving to an infrastructure as a service, then we're going to be using the networking, storage, and servers only. All the middleware, all of the data and applications, we are going to have to move that to the cloud, and ultimately we're going to be responsible for maintaining that in the cloud. We're still going to get the benefit of the cloud vendor providing us with storage and servers. If we move to platform as a service, we go up the stack. Now we're using middleware. Perhaps we're using an application server that's provided to us by a cloud vendor, and then we are still responsible to get our applications running and our data running on top of the platform as a service. If we talk about software as a service, we typically think of a vendor, one of the first vendors, of course, was Salesforce. Then we're really using the whole stack. The cloud vendor is providing everything, including the application. So it's important for us, of course, to know, based on our application, we may choose infrastructure, we may choose platform, we may choose software as a service, depending on the type of application that we have. So let's take a look at the deployment models. If we talk about our on-premise application, as I said, we might typically move it to a public cloud, which is going to offload all of our compute resources, perhaps even our application server resources. If we move it to a private cloud, it may be residing in the same data center as on-premise. If our on-premise hardware and software is located in this building, perhaps our private cloud will also be located in this building. Again, we're not going to realize the benefits of offloading, but it does give us the same benefit of being able to gain resources, get resources on demand. What about service models? How do we choose which service model we're going to migrate to? A lot of it is going to depend on the type of application we have. So let's say we have a Java-based application that we've written, perhaps on top of an application server with a database backend. That would actually be a perfect fit for platform as a service, because platform as a service is going to typically provide us with a database in the cloud, typically going to provide us with an application server in the cloud. Now we should be able to fairly easily move our Java code by redeploying into Platform as a Service. What about if we have native code? Maybe we have code written in C or other languages that's natively built for that particular platform. It's not based on Java. We could still migrate to the cloud, but then we probably want to consider infrastructure as a service. If we're moving into a public cloud, we're going to be taking advantage of the public cloud's resources, that is storage, networking, and servers, and we're going to be deploying our non-Java code into infrastructure as a service. We're going to focus less on this talk on software as a service, but if we did have some packaged application running on-premise, we may want to consider moving to a software as a service vendor. Right? Less of a migration, it's more of really retooling to take advantage of what the software as a service vendor has to offer. So let's take a look at an example of what a public cloud looks like. This is based on Amazon, their EC2 offering. And we can see here that we have 3 regions listed over here to the left. We have US East 1, EU West 1, and other regions. Those regions, of course, are spread across the world. A vendor like Amazon is going to have various regions spread across the world. And inside of each region is what is known as availability zones. Now, each availability zone is separate and apart from one another. That is, they're going to have separate networking, separate electrical, everything completely physically separate, other than the fact that they're located in the same region, perhaps even in the same building. If we look at the picture to the right, we can take a look at what's inside an availability zone. Each availability zone is going to have instances. An instance really is a virtual machine. If we're talking about Linux, we're going to have the ability to create various VMs that then we can use, and each of those VMs would be associated or would be connected inside an availability zone. Let's take a look at what we see if we're using Amazon, for instance. And this is actually my account based on this is basically a free account, which anybody is entitled to. It entitles you to a 1 gigabyte VM, which I have running here. You can see here that happens to be running an availability zone US West 2A. And you can see that I also have another machine above that running an availability zone US West 2B, which at the moment happens to be stopped. But the one that's running, you can see that it has a public IP. So we can access it from the outside world. And in fact, I happen to have WebLogic running on it. And I deployed a JSP to it. Happened to deploy using Eclipse. Very simple JSP running in the cloud. And you can also see that we have Oracle WebLogic Server running. This is a console also running in the cloud on our Amazon virtual machine. So let's take a look deeper at what is actually what do these VMs really look like inside of a cloud vendor. And in many cases, it looks the same within an on-premise environment as well. But we know in the cloud, we're going to have virtual machines. Cloud vendors are not providing physical machines. On-premise, we might have a mixture. We might have physical machines. More and more, we see on-premise also having virtual machines. The picture on the left shows your typical hypervisor. We use a hypervisor such as VMware or Xen, and running on top of that hypervisor are our operating systems, the VMs, Linux or what have you. OS A might represent the VM that I just showed on Amazon. Now the picture to the right is what we call container-based, such as Linux containers. It's also what Docker happens to be running on top of. So here we have a container engine, and we have libraries running on top of that container engine. Each of those libraries is sort of analogous to the operating systems we have on the left, except that it doesn't have a complete copy of the kernel. So it's a much lighter weight version of a VM. Container-based deployments are much easier, much faster to instantiate and deploy, which is why it's becoming very rapidly very popular. In either of those cases, it enables multi-tenancy. Why? Because now we can have, on a single physical machine, a single server, we can have multiple tenants running. I, as an organization, might be assigned OS A, or a library associated with App A. There might be another organization that's assigned OS B, or Application B. There could be multiple organizations or companies running within a single physical environment. So let's talk about platform as a service. What are some of the key use cases associated with running on platform as a service? Well, number one, I might want to use a platform as a service to do development and testing. Say I'm building a Java application on top of an application server like WebLogic. It's going to require a fair amount of machines to do development, to do my testing before I even get to production. And rather than have all that equipment purchased and on my premise, I can use a cloud vendor to be able to expand. And then contract, perhaps when the schedules don't require as much hardware anymore. Of course, what we're talking about today is really lift and shift, migrating workloads to the cloud. So here I have an on-premise application built on top of, say, WebLogic server. Now I want to move it to the cloud. I'm going to migrate, and perhaps it's using a workflow, perhaps human workflow, or people. I can move those applications on top of platform as a service. And after moving that application to platform as a service, I might want to extend the application. I might want to add features. I could do that in the cloud. We talked about multi-tenancy before as it relates to infrastructure as a service, using the same server to serve up multiple VMs, perhaps to different organizations. And the same is true in platform as a service. So here we see what we can do with a database. This happens to be based on Oracle's database, which now in the latest release, 12c, provides the notion of PDB, or pluggable database. I can have a single database container, and I can have multiple PDBs running within that container. Perhaps PDB1 would be running an ERP, PDB2 would be running a CRM. Perhaps all those PDBs are for a single organization like ours. Perhaps some of those PDBs are from other companies. And this is really what allows cloud vendors to achieve what we talked about before in terms of having okay, I shouldn't do this. Yeah. Economies of scale. Right? One of the ways that cloud vendors can achieve economies of scale is by enabling multi-tenancy, not only at the infrastructure level, but also at the platform level, such as we see here with the database. And much can be said for your IDM layer, or your LDAP. Much can be said for your application server layer as well. So let's talk a minute about a hybrid cloud. We talked before about combining a private and a public cloud. Why might you want to do that? Well, a private cloud is good if you want to provide a service to a company's own employees, but perhaps you want to control access. maybe you have security concerns. Maybe there are applications that we just are not ready to put in the cloud because of security concerns. So we're going to leave those applications in a private cloud. But maybe other applications we're going to put in the public cloud in order to take advantage of what we talked about before, cost saving, scalability, etc. But perhaps those applications need to communicate. We might have an ERP system, an HCM system, one in a private cloud, one in a public cloud, that need to communicate. And therefore, integration is going to be critical. Going to need to have the applications in the public cloud and the applications in the private cloud, the ability to communicate among one another. So we've talked about the various options of public cloud versus hybrid cloud. We've talked about the different models, infrastructure, platform, software as a service. But we also have to consider things like high availability and security. Perhaps when we built our application on premise, we had a strong desire for high availability. Uptime, really important, 24/7 by 365, and we just can't afford unplanned downtime. Well, if that was the case for our on-premise app, when we move it to the cloud, we want to make sure that we're going to get at least that level of high availability from the cloud. So some high availability solutions. One, the simplest would be auto restart. Process goes down, we want to be able to make sure that we can restart it. We also have the notion of active-active, where I might have two nodes that are serving up requests. If one goes down, and they're both active, if one goes down, the other node needs to pick up the load so we don't experience any downtime, unless, of course, all our nodes go down. In an active-passive situation, we have one node that's up, one node that is not currently operating, but is ready to take over if the first node goes down. And then lastly, we have disaster recovery, which is we have a whole nother site, perhaps East Coast versus West Coast, which is on standby, ready to take over in case there's a disaster, such as an earthquake. So let's take a look at what high availability looks like on premise. This is an active-active scenario. This is actually based on the Oracle's Fusion Middleware High Availability Guide, which we decided to follow when we built our on-premise application. So we have requests coming in. It's coming into a hardware load balancer, perhaps an F5. That load balancer is routing to one of two HTTP server instances. Happens to be running Oracle HTTP server. And from the HTTP server, it's routing requests to one or more WebLogic managed servers. So there are various high availability built in here. Number one, let's say one of the OHS instances were to go down. The system is smart enough to detect that, and it's going to restart it. Number two, let's say an entire node fails. Now, by the way, we're assuming that OHS and WebLogic Managed Server 1 are on a different machine than OHS and WebLogic Managed Server 2. Let's say the whole physical machine goes down. What's going to happen is that the other OHS and the other WebLogic Managed Server will be picking up the load until we can bring back the first node. Similarly, at the WebLogic server layer, if one of the WebLogic managed servers go down, the other managed server will pick up the load. If there's any state, then the state will also be transitioned over to that second managed server. So from someone who's accessing this application from the browser, they would not experience any downtime. So now we want to take our high availability solution and put it in the cloud. So what is it going to look like? Now we need to go back to what we talked about with availability zones. We talked about that an availability zone is a single site cloud with equipment even coming from separate power supplies. Each availability zone is totally separate, even though it might be in the same region. So what we're going to want to do is put an HTTP server and a WebLogic server, say in zone 1A, and the other HTTP server and the other WebLogic server in zone 1B. That will ensure that if there's a power glitch, or if a node goes down, or whatever, that we're not going to impact our entire application. We still have the other availability zone that's up and running. What about disaster recovery? We take a look at Oracle's Fusion Middleware Disaster Recovery Guide, and we see that there's two parallel topologies going on. Topology on the left would be in one region in the world. Topology on the right would be on another region in the world. The topology on the left is our active one, that's up and running. The topology on the right is on standby, ready to take over if there is some sort of disaster, where, let's say, our entire building goes offline. Replication has to happen at various levels. So there is going to be WAN traffic, could be expensive, but we have some applications where it's absolutely important that we have no downtime. We need to spend the extra money. We've done that on premise. This is what we've presumably built for some of our applications to make sure that we prevent a disaster from impacting our business. How is this going to look in the cloud? Here we're going to take advantage of regions. So rather than the high availability solution, where we're taking advantage of different high availability zones in the same region, now we need to take advantage of different regions. So in this example, using Amazon, we have US East and US West. US East is the active one. US West is ready to take over. There's replication that's going back and forth, so that US West has a fairly recent copy of what US East has. If there's a disaster, say a hurricane hits the East, power goes out, US West is ready to take over. Interestingly enough, a couple of years ago, Amazon actually did experience an outage, which affected quite a number of companies. Foursquare, for instance, was down for several hours. What happened? Amazon's Virginia data center went down. Through a series of issues, the entire data center went offline. Foursquare had redundancy, except they built for a high availability solution. So their redundancy was in the same data center. Different availability zones, all in that same data center, which didn't do much good when the entire data center went down. Another company you might have heard of, Netflix. They were also using Amazon. They still do. They were using the Virginia data center. But Netflix paid extra money to have disaster recovery. And so when the Virginia site went down, disaster recovery happened to another site in the world, and Netflix only experienced a minor glitch versus other companies that experienced a major outage. So in those rare times when disaster recovery hits, if we really need that high availability, that level of high availability, when we go to a cloud vendor, we have to be mindful of that and make sure that the cloud vendor, first of all, that we're paying for it, and second of all, of course, that the cloud vendor can provide that same level of reliability for us. Let's talk about security and privacy. It's probably the top concern that organizations have about migrating to cloud. Speak to vendors in the financial industry, for instance, very reluctant to move their applications to the cloud. It's running on premise, it's very sensitive data, and we know that various breaches have happened. We've all seen it. Many of those breaches have actually happened when the data was on premise. But when data is let out into the cloud, it's a big concern that companies have, especially for those companies with very highly sensitive data. So some of the risks would be compromised or unauthorized modification of cloud resident data. One such example of such a risk would be what would known as a side channel attack. Let's say our company, we're allocated a VM in a certain availability zone, and some rogue hacker happens to get a VM located on the same physical machine. There's that possibility that through a side channel attack, they can gain access to our VM that's located on the same physical machine. That's something to be careful of. It might be a reason for us to consider in certain cases to pay extra money to get access to an entire physical machine. Denial of service attack is one thing. So if we're sharing perhaps the same physical machine or even perhaps the same availability zone, maybe there's some other company that experiences denial of service attack, and guess what? We're also impacted by that same denial of service attack, even if the attack wasn't against us. So this is just a sample of some of the risks associated with security and privacy. But what can we do to remediate some of those issues when we move our applications to the public cloud? Well, one thing we might want to consider is making sure that the cloud solution is based on a hypervisor rather than a container. We talked about those two solutions earlier. Hypervisor tends to have more separation between VMs. Container VMs have less separation. So it's less likely that a side channel attack could happen in a hypervisor case versus a container case. Another thing we could look at is having the cloud vendor provide a service gateway. So it's an additional level of protection where we might have our own virtual private cloud. So rather than be allocated random IPs, for instance, our IPs would all be in our own subnet. Nobody else would be allocated IPs in that same subnet. That gives us a little bit extra protection. The other thing, of course, is that we need to consider identity and access management. Our LDAP, for instance, which now is running on-premise. Now we need to decide, are we going to leave our LDAP on-premise and have our cloud solution point back to our on-premise LDAP? That's one possibility. Or we might decide to move our LDAP into the cloud as well. In either case, we want to make sure that we're leveraging our same LDAP infrastructure, all the content in there, so that we know somebody's coming in, we can verify that that person is who they say they are, and also we can gauge what they are entitled to have access to. But we also have some applications that we, as an organization, might have decided our management is just not going to let this go into the cloud. It's just too risky. We can't even propose that. What are the possibilities for those applications? Is cloud still in the picture? The answer is yes. First of all, we could leverage a hybrid cloud. We can say that we're going to use the public cloud for either non-sensitive data or for compute functions. But we're going to store any sensitive data, maybe it's company, maybe it's employee records, maybe it's customer records. We're going to store that on our own private cloud, which is in-house. And this is where integration becomes important. If we use a solution, we're going to have to make sure that we have proper integration between public and the private cloud. Secondly, we might decide that we're going to use the cloud only for development and testing. That's a viable solution too. We're going to deploy, when we get to that point, we're going to deploy on-premise, where we're going to do all of our dev and test in the cloud. So we don't have to purchase extra machines, have a bigger lab to support machines for development and testing. So there are a couple of possibilities that we have, even for cases where we know we're not going to deploy that application fully, at least into the cloud. So let's spend a few minutes talking about what Oracle offers. Oracle's cloud platform is infrastructure, platform, and software as a service, all three levels. In addition, Oracle provides the ability to deploy into a public cloud or a private cloud. It's our choice. The infrastructure is going to be the same. We can choose to deploy some of our applications on top of Oracle's public cloud. We can also buy hardware from Oracle to run those same applications with the same level of rapidly gaining access to environments and deploying, but doing it on-premise. It's a complete suite of PaaS and infrastructure, simplifies application development, and provides a single extension platform for SaaS. So say we decide to use Oracle for CRM or HCM, and we need to extend that. We need to extend our application because no SaaS vendor is going to provide everything we need. We can use Platform as a Service to extend the SaaS solution to provide exactly what we need. Scalable, high available, all the things that we talked about before in terms of security, high availability is of course all built in. So here we see that we have various levels of the stack. We have WebLogic Suite, JDeveloper for building our apps. We have Tuxedo. We also have suites on top of the basic WebLogic, such as SOA, BPM, document management. It's all available, and more features coming in the cloud from Oracle. Talking about the Java Cloud Service, that's really Oracle's answer to providing an application server in the cloud. Of course, it's based on WebLogic, and it provides us a way of moving our applications built on Java using an application server, redeploying on top of the cloud. Some of the main use cases we can talk about, first of all, we can use Decide to do just dev and test in the cloud, but deploy on-premise. I want to focus for a minute on migrating applications to the cloud. This is also called lift and shift, and this is what we're talking about, taking the applications that we built, moving it onto the cloud. What are the advantages of using a product like JCS? First of all, lower cost. We don't have to have our own data centers anymore. Scalability. Now we no longer need to start purchasing our own hardware. We can get it from our cloud vendor, in this case Oracle. We need more hardware, we're going to the cloud vendor for that. We need to scale back because maybe it's off-peak season. We can do that. We're only paying it as we need it. We also have the flexibility at any point to move back to on-premise. Say we've gone to the cloud, we want to then move back to on-premise. Oracle's Exalogic provides the ability to deploy your cloud solution, but as a private cloud. We see that cloud and PaaS adoption is really taking off. Right? More and more companies are exploring, looking into moving to the cloud and taking advantage of what the cloud has to offer. The growth is really becoming exponential, as you can see here. Many companies are looking at not just our organization that's here, but many companies are looking to use the cloud either now or in a couple of years from now. And in particular, we see even further growth within Platform as a Service, for the reasons and the benefits that we talked about earlier. In closing, I would say that where the cloud is ultimately going, where cloud computing will ultimately end up, and whether it will have the same impact as the electrical utility has had, that remains to be seen. But perhaps 100 years from now, software engineers will be gathered at a conference talking about the latest technology in the future, wondering whether that technology will be as pervasive as cloud computing has become. Okay, we have a few minutes for Q&A. Thank you, thank you. Do we have any questions? Michael has a whole page of questions.
Well, mostly feedback.
Oh, okay. Okay, feedback's good too. I'll take either Q&A or feedback. Go ahead.
One question which is not exactly in the same, a little bit off the topic, but it is for the account which we hold, free account for Amazon. You mentioned that there is a free account wherein we can have access to